Hello students, so here we are going to look at assignment 3.3 where we take a closer look at our quadratic functions, right? So here we go. Um, well, don't be don't okay, I know suddenly a lot of things happen on the screen, right? So what happened here is they want us to express y equals to 20 minus 5x minus x squared, yeah, in that form. So basically what they want us to do first of all is to express the quadratic function in this completed the square form. So there are two ways to go about doing this, which is why I have half the screen written in blue and the other half in red, because there are more than one method. So I thought I will show you two options, and you just use the one that you're more comfortable with, right? So let's take a look at the blue line first. So on the blue section here, what we did was to identify the coefficient of x squared, x, and as well as a constant term. So we just call it a, b, c, right? So you look at it, rearrange it, and then identify a, b, and c. Now I did ask you to memorize the fact that h is equals to negative b over 2a. So when we do that, we can find h straight away. Okay, so after finding h, it is negative 5 over 2, or you can write negative 2.5, it doesn't matter, they are equivalents. And in order to find k, we take this value of h and substitute it back into our original equation. So when we do that, we find k. So once we have our h, we have our k, we can actually write it in the form that the question asks for, right? So yeah, so this is completed the square form. Finally, to answer the question, they ask us for the line of symmetry. Well, the line of symmetry is just x equals to h, so this is our value for h. And the maximum value of y is actually our k. So yeah, just write down, right, value of k over here. Okay. So what happens on the red is actually a alternative method that we can use to find to get the completed square form. In fact, it is actually the process called completing the square, right? So it's actually the more natural way to do it. However, I do understand at this stage some of you may find difficult, but hopefully with some practice, by the time you go to upper secondary, you will be a lot more proficient in using this method. So here we have what we do is we identify that okay, a is actually negative 1, so I'm going to take out negative 1 as the common factor, and so that I have a positive x squared over here, right? So this is what I do. I take out negative 1 as a common factor. After that, I complete the square by introducing 5 over 2 square to it, right? So I add 5 over 2 square and subtract 5 over 2 square. How do I get 5 over 2? I just take the coefficient of x, or rather the value of b, I divide it by 2. Then I square it, right? So I add that value, subtract that value. After that, the first three terms here, okay, actually is a nice perfect square. That's why this is called completing the square. Okay, and of course the values at the back here, we can just calculate it using a calculator. It's negative 26 and 1/4. So so with this, after that, the common factor that we took out right at the very beginning, the negative 1, well, we distribute it back in, expand out the square bracket. This is our form, completed square form already. So once we have completed the square form, we identify the h, right? Identify the k. Identifying the h and identifying the k allow us to answer the question of what is the line of symmetry as well as the maximum value of y. Okay, so yeah, I know some of you may take some time to digest what's happening on the screen, but I hope you are successful. If you need to listen to my explanation again, feel free to rewind and try again. Okay. Right, another practice here, but this time round, instead of converting it to the completed the square form, they want you to change the function to this one, right, the factorized form. So we are going to well, just perform factorization, which is of course a technique that you have learned previously, right? You can just use the cross method here. So after factorizing, we have this, but of course you realize that the coefficient of x in this factorized form is actually 1. So what we need to do here is, after we factorize this 2x minus 9, I need to extract out 2 as a common factor. So the 2 is actually my a, right? So I take out the a, which is 2, and what I have left inside here will be x minus 4.5. The other one is fine, right? X plus 2 is just x minus negative 2 is there, it doesn't matter. Okay, but the reason why I write it this way is so that I can then identify the value of p and q properly. So value of p here is 4.5, value of q here is negative 2. why do I extract out the value of P and Q? Because of the next part of the question. The next part of the question asks us for the line of symmetry, right? So line of symmetry means I need the H, and another way of obtaining H is to find the average of the two roots, right? So in this case, average of P and Q, my H is actually 5/4. That means my line of symmetry is x equals to 5/4. Here we go. Okay, and of course we need to find k in order to get the minimum value of y. So how to get k? I just take my value of h, substitute it back into my original equation, and my k is a negative 21.125. You can write it in a fraction form. It is okay as well. Okay, that means that my minimum y is actually negative 21.125. Okay, so that's how we do this question. Yes, one more question. Now this question is slightly more challenging. That's why in the worksheet that I gave you, it is not tier C. But I actually, if you have understood everything that I've taught you in class, you actually can handle this, right? So what we want to do here is we want to complete the square, because they say it cannot be smaller than this value. If this expression cannot be smaller than this value, then this value, it makes sense that this value is actually the minimum value, right? So how to get the minimum value? The minimum value is our k. So if I complete the square for this expression here, I complete the square, then the k value is going to be my smallest possible value, right? So I complete the square. This time round, coefficient is 2/3. Yes, the coefficient can be fraction like this, I know, right? So take out 2/3. This is what I have, and then after that I complete the square. I see 3p/2. I divide it by 2, so it's 3p/4. I square it, so I square this. I subtract it so that the value don't change, and of course negative 3p/2 is still here. Okay. Now the first three terms here, okay, factorize into this, right? We have x minus 3p/4 square, and then down here I can square this bracket here, so it's 9p square over 16. Okay. After we get this, we multiply the 2/3 back in. Okay, we expand the square bracket. So we multiply in. Down here we can't go in because of the square here. I can't go inside the bracket. But over here, okay, so times 2/3 times 2/3, this is what I get. So that means that my h right now is 3p/4. My k is this entire expression over here. Okay, my k is negative 3p squared over 8 minus p. So this is my k. My minimum value is my k, right? So this is a minimum value. I make them into the same denominator, and then I extract out common factor, and hey, it looks exactly like what I'm trying to show. Mic drop. Okay, so well, I hope many of you are actually successful with this. It made me very happy that you are successful on your own in the first attempt, and all you need to do is look at my solution and say, I got the same thing. That would be great. Alright, so yeah, so this is the assignment that I gave you. Have a nice day.